Hi guys. Separation is covered on the final exam in a very particular way. Most of the separation that we did this year was lab-oriented, right? We had to figure out how to get things apart in the lab. But this is a pen and paper test, so you're going to be asked multiple choice questions about separation. And the key thing that I'm looking for you to be able to do is to be able to know which techniques match up with which characteristic properties. So let's go through them. You've got, I'm going to write in, let's see what color, let's do blue. There we go. You've got the techniques listed for you. So filtration is a technique that we used. You need to know what it is when you filter something, and I think you do, right? This is where you take a funnel and you put some filter paper in it, and you pour a mixture through it, and anything that does not dissolve stays in the filter paper, and anything that does dissolve goes through with your liquid. So that process separates using differences in solubility. So it only works, you can only filter one thing away from another if they have differences in how soluble they are, right? So for example, salt and sand. Salt dissolves in water, sand doesn't dissolve in anything. Mix them together, it can be really hard to pull those sand grains away from your salt grains because they're both really small. But if you add a little bit of water, stir it up, and filter it, the water will contain the salt because the particles of salt are now small enough to pass through the tiny holes in the filter, just like the water does. But the sand is too big and it stays behind in the filter paper. That's because the sand doesn't dissolve and the salt does. So you see how filtration is really a separation technique that uses differences in solubility for it to work. So what's the difference in flotation? If I put sand and sesame seeds together and try and separate them by putting them in water, neither one will dissolve, but one of them will float and one of them won't. Well, why does one float and the other one sink? What's the characteristic property that they have that's very different from each other that allows that to happen? Answer, density. Sesame seeds are less dense than water, so they float on the surface of the water, usually. Sometimes they need a little encouragement. The sand, however, is more dense than the water, so it sinks. You getting the idea here? So separation techniques take advantage of some characteristic property that your mixture's components differ in. Fractional distillation, often confused with fractional crystallization, right? If you get confused, you can say to yourself, well, which one of these sounds like there might be a solid involved, and solids crystallize, right? So fractional crystallization is when you're dealing with solids. Fractional distillation is when you're dealing with liquids. When we do fractional distillation, what are we really using to get our liquids apart? So we have a mixture of several liquids, like our cherry Coke or your sludge had several different liquids in it. And what do we do to get them to come apart? We boil them. And what we're counting on is that each liquid will boil at a different temperature. So the characteristic property being used here is boiling point. This is very different from fractional crystallization, which sounds similar but is a totally different thing. Fractional crystallization is a fancy type of filtering. It's a kind of filtering. When you do a fractional crystallization, you filter one substance away from another. But this time, you don't just add water at room temperature. You add hot water so that you dissolve just one of your substances, but not the other. And that's because they have differences in solubility at high temperatures. So they have differences in solubility that are really significant at higher temperatures. When you do fractional crystallization, usually both substances will dissolve in your water. You do it with stuff like potassium nitrate and salt. Both of those things dissolve in water. But potassium nitrate dissolves way better than salt does at high temperatures. They have roughly the same ability to dissolve at room temperature, but at a really high temperature, the solubility of potassium nitrate shoots up, right? You can think about that solubility curve with salt and sodium chloride on it. Salt and potassium nitrate. If my salt is the green line, as temperature increases this way, the salt solubility doesn't increase very much with temperature. However, the potassium nitrate jumps up. So here at a high temperature, you can see that they have very different solubilities. In order for fractional crystallization to work, you have to use tiny amounts of water so that you don't just dissolve both of them all together. And that was the mistake that many of you guys made with your sludge, and also when we did the fractional crystallization lab, was that you would add too much water, they would both totally dissolve, you'd get nothing left in your filter paper. This is a very tricky process, fractional crystallization. The good thing is for your final exam, you don't actually have to do a fractional crystallization, you just have to realize what it is. It's using solubility just like in a regular filtration, but doing a filtration at a higher temperature with lower amounts of water. Finally, magnetism, quite obviously, uses magnetism. This one's a really easy one. So if one substance in your mixture is magnetic, you can easily pull it out with a magnet, and you're depending on the fact that one of your substances is magnetic and the other isn't. If they're both magnetic or they're both not magnetic, you can't do a separation. And that's really all you have to know about separation. But I find that on this final exam, some of the hardest questions for students seem to be these separation questions. And I find that interesting because it's actually one of the units that you spent a lot of time on, and I know many of you know a lot about this stuff. And yet, somehow, you guys don't understand the way I'm asking the question. So let's do a practice one so you can see what it is you need to be able to do. Okay, here's a typical question from the final exam about separation techniques. Take a minute, try the problem, guess your answer, and then listen to what I have to do. You can pause if you need to. Okay, so first of all, notice that the question asks you for a characteristic property, not a separation technique. So that should make you eliminate A and B right away, because those are separation techniques, not characteristic properties. Then it gets a lot easier. Which of these two things is going to be useful for getting sesame seeds away from sand? Well, neither one of them dissolves, so it's not solubility. It's got to be density. You see how I did that? Make sure you read the question carefully. Is it asking you for a characteristic property, or is it asking you for a separation technique? They're totally different things. They're related to each other, but you have to know which one refers to which. Characteristic properties are things that you can measure about a substance. Separation techniques are processes that you do to mixtures. Make sure you get that down. The other way I could ask this question, instead of saying what characteristic property can be used, I could say, what separation technique would you use to separate two substances that do not dissolve but have different densities? I'll write that for you so you can see what that looks like. Okay, so what separation technique can be used to separate two insoluble solids? Well, this time I am looking for a separation technique. So I can eliminate things that are characteristic properties. That's a characteristic property. That's a characteristic property. The question is asking me, what technique do I use to separate two insoluble solids? What does that mean? Well, two insoluble solids cannot be separated by filtration because neither one will dissolve. However, they could, if they have different densities, be separated using flotation. So you have to think a little bit when you're looking at these questions and make sure you're reading the question properly, eliminating, if it's asking for a characteristic property, eliminate separation techniques and vice versa, and that way you should be fine on the quiz tomorrow and on your final. See you guys in class.